This episode of the Pumps and Systems podcast is brought to you by Hydro International, recently acquired by Oldcastle Infrastructure.
Usually a plant will have an average daily flow and a peak hydraulic flow. And because the collection systems are miles of pipes underground, what we see is a lot of solids will settle in the collection system and then they'll have a rain event. So you see a peak flow go to a facility. If you're not designed to remove solids at that level, you're going to miss a lot.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor with Pumps and Systems magazine. In this episode, we're speaking with Liz Halleck, regional sales manager for Hydro International, which was acquired by Oldcastle Infrastructure last year. Liz is going to be telling us all about fine grit removal at wastewater treatment plants and why it's so important to plant operations. So without any further ado, let's get into the episode. I will start by welcoming you to the Pumps and Systems podcast. So welcome and thank you for being here. And how are you today?
I'm fine. Thank you for having me.
No problem. So I'm not sure where you're located, but have you been having to deal with any of the heat wave situation?
Yeah, it's been warm all over, really. Yeah, I'm on the East Coast in Michigan. So yeah, it's been warmer than normal here as well.
So today we are going to be talking about grit removal. But before we get into that, would you mind telling us a little about yourself? So tell us who you are, where you work, anything that you think our listeners and viewers might want to know.
Sure. My name's Elizabeth Halleck. I work for Hydro International. So Hydro International was acquired by CRH middle of last year, but we're really known for fine grit removal, right? So we have two divisions here in the U.S., one in Maine that's in stormwater and works primarily with stormwater. And then the division I work for, which is wastewater. And so we're concerned with fine grit removal in the municipal wastewater treatment plants.
So then with that makes for a good segue into our main theme, which is grit removal. So let's start with just the absolute basics. So what do we mean when we're talking about grit and removing it?
Yeah, so grit is just an inert particle that travels to the wastewater treatment plant. So it kind of gets combined with organics such as fats and greases, and it comes in the collection system through our sinks, washing, dishwasher, clothes, and any pipe breaks, infiltration. So it's a nuisance material. It's very abrasive, and it will damage equipment inside the treatment plant as well as increasing operational costs, reducing equipment life and performance of the treatment plant.
Okay, so then it sounds like it's rather important to get rid of it then.
Yeah, I mean, it really needs to be managed in the front end or the headworks of the wastewater treatment plant, because if not, it will continue to get into the downstream processes. Grit will settle at the widest spot it can, whether it's an aeration basin or a digester. And if it does that, then it reduces the detention time. It affects the treatment plant's efficiency in treating the wastewater equipment. It can increase the costs of operating a plant because, for example, like in an aeration basin, for the blowers to work efficiently, you need, to use air compressors, electricity. Well, eventually you'll get enough grit that it's going to bury those. So you'll need more power and more energy just to operate the facility. And the same with digesters. I mean, it can mess with the gassing and how the digester, and it takes up volume.
So how exactly does grit removal work? What is the process there?
Since grit's like a discrete particle, if you can remove it as it comes into a facility, it's easier. It's not bound up with the solids, the municipal waste that we're going to see. So we kind of look at it as a three-step process. We collect the grit, we separate the grit, we wash the grit. And because it's discrete, it's really a consideration of retention time. How do you maximize the surface area so that you can collect the particles and settle, or how do you get enough retention time in the front end of the plant. So it generally comes right behind screening. So as the flow travels to the wastewater treatment plant, it gets screened, and then we do grit removal and before it goes on to the other processes in the treatment plant.
So why is it important to remove fine grit specifically?
Fine grit is, and it's pretty small, just so you know. Well, Hydro International focuses on removing 95% grit of particles 75 micron and larger. So a lot of the old treatment facilities and treatment equipment that is in the industry really targeted 300 or 2 to 300 micron. So an analogy to that would be to say like a 75 micron grit is like a 220 grit sandpaper, where the 300, if they made it, it's really coarse. It's like a 50 grit sandpaper. So we target the fines, and the reason we do that is there's a significant volume of grit that is finer that comes into a treatment plant, and also as the coarse grit kind of sits in a collection system, right? It gets some fats, oils, and organics adhering to it. So when it travels under peak conditions, it doesn't act like a heavier, larger particle would. Sometimes it needs more time to settle. As the larger particles come in, it just needs more time. It behaves like a smaller sand particle. And so therefore, we just really want to capture and maximize the efficiency of the grit removal.
Yeah, it sounds like a difficult thing to remove something that is that small. So how is that done exactly, or how is that done effectively? Maybe I should ask.
We developed over 30 years ago really a way to maximize. We treat it like a clarification issue. So our equipment maximizes the capture, allowing the fine particles to settle. We give it extra surface area and retention time. So the loading rate is there in order to capture those particles. The older systems, the mechanically vortex, the aerated grit basins, they're really only capturing about 50% of the incoming grit to a facility. So that means a significant amount of grit still travels downstream into the treatment plant. So there was a study presented in a 2009 WEF workshop that illustrated that if you only removed 50% of the incoming grit, you would bury those diffusers in a 1 foot grit basin within 2 to 3 years. So if you can increase the efficiency removal to 90%, then it would now take 8 to 12 years before you had accumulated that same 1 foot. So we're not going to capture everything, but we're trying to maximize the capture efficiency through the treatment plant.
This episode of the Pumps and Systems podcast is brought to you by Hydro International, recently acquired by Oldcastle Infrastructure. As a global leader in water management technology, we offer advanced, sustainable solutions like HeadCell, a stacked tray grit separator, and Hydro Grit Cleanse, a grit washing and dewatering system. To find out how our grit removal expertise can reduce the cost of cleaning, maintenance, and repair while increasing plant efficiency, visit hydro-int.com/grit-removal. Is removing fine grit something that only the large municipalities do, or is it done elsewhere as well?
No, so we have developed some treatment systems that allow us to treat the smaller units. It's a compact line that was developed using our technologies, both from the stormwater side and our wastewater side. It allows it to be plastic internals and be inserted in a precast concrete tank, but that reduces both the cost of construction and the footprint required for installation.
And is grit removal something that every wastewater treatment plant does?
There's a lot that still don't, or they think that they have effective, like it's the cost of doing business, right? Like what else will the guys be doing if they're not shoveling those out? But it's a very expensive process. If you think about it, when you have to take a basin down and put people in there to shovel around diffusers and empty the solids. So it is important if we get them to understand, but grit isn't regulated by the permit. I mean, there's no regulation on grit. So really getting them to understand that there's a cost to grit coming into a facility, and that if you can minimize the cost by removing it up front before it's entrained or combined with those solids, then that it's better for the overall treatment processes and the effluent that they produce.
So the idea is to kind of catch it before it becomes the problem.
Yeah, I mean, really, we want to remove it while it's still inert, while it still only has a little organics attached to it. Once it travels into the aeration basin or a digester, it kind of becomes entrained with that material. So it damages the pumps, it damages the dewatering equipment, because it's really abrasive. I mean, we're talking something that is like, it's like sand, but it's not. It's got a little more to it.
Okay, so we still have a little bit of time left. So do you have any real life stories or examples that you'd want to share, like something that shows us the wonders of grit removal?
It allows a facility just to operate better. So even removing up front, I was with an engineer recently, and he was telling me that improving by putting our head cell in, that the whole plant is just operating much more efficiently, that they're not having as many operational problems as they would have. And so we see that over time and in different papers and different case studies where upfront removal really does save downstream costs.
So then what would be your number one piece of advice for someone considering grit removal?
I think it's just looking at overall the process, right? Designing for peak removal efficiency. So usually a plant will have an average daily flow and a peak hydraulic flow. And because the collection systems are miles of pipes underground, what we see is a lot of solids will settle in the collection system, and then they'll have a rain event, so they increase the flow. So you see a peak flow go to a facility, and that if you're not designed to remove solids at that level, you're going to miss a lot, right? Because you're just going to get inundated with it. So our systems are always designed for peak hydraulic loading and grit removal at that flow, and then just efficiently look at each step in the process, because if you caught 90% of it, you really want to keep 90% as much as you can. So let's look at the washing step and then the dewatering step so that you maximize capture efficiency in each step of the process.
So before we wrap up, is there anything else you would like to share, or any final thoughts you want to leave our listeners and viewers with?
I would just like them to understand that, there is a science to grit removal. That all equipment isn't created equal in the upfront grit removal process. And just because you see grit in the system or in your dumpster doesn't mean you have an efficient removal. A lot of times what we see is a lot of organics that have been captured and not necessarily grit. So it's just important, again, to reiterate that we look at the whole process of grit removal and get the appropriate equipment for them.
Okay, well then, thank you so much for taking time out to speak with us. We really appreciate it.
Thank you for your time.
Huge thanks to Liz for taking the time to talk with us today about the process of fine grit removal. And big thanks also to Old Castle for sponsoring this episode. If you're listening to the podcast and would like to watch it, head over to our YouTube channel to check out the full video version. That's going to do it for today. Thank you so much for watching or listening, and we will see you next time.